This is the AI story that no one saw coming. The most powerful AI are now open source, and it changes everything. In the last few weeks, the game has been completely rewritten. In our new video, we're breaking down the 3 massive releases shaking up the industry. Z.ai GLM 4.5, delivering elite performance for pennies. Kimi K2, the first truly agentic AI that acts on its own. And OpenAI GPT-OSS marks OpenAI return to open source after 6 years and democratizes cutting-edge AI for everyone. This is more than an update, it's a revolution. So, let's start our review with a new open source model that outperforms major competitors like Claude 4 and Google Gemini 2.5 Pro at rock-bottom costs. What exactly is this powerhouse? It's called GLM 4.5, and it's the latest open source model series from a company called Z.ai. So what exactly is GLM 4.5? Well, think of it less like a simple chatbot and more like a complete, all-in-one AI agent. Z.ai's primary goal wasn't just to build a model that's good at one thing, like writing or coding. Instead, they engineered a unified system that natively integrates high-level reasoning, complex coding, and autonomous agent capabilities all into one package. It's designed to be a thinking system from the ground up, and it's not just one single model. GLM 4.5 is actually a model series. You have the main flagship GLM 4.5, but they also released a lighter sibling called GLM 4.5 Air. This is a more compact version specifically designed to run on more accessible GPUs, making this powerful technology available to users and developers who don't have massive amounts of compute power. It's all about balancing elite performance with real-world accessibility. So how does GLM 4.5 actually manage to be both a powerhouse and efficient at the same time? The secret lies in its core architecture. Under the hood, it uses a clever design called a mixture of experts, or MO. The main GLM 4.5 model has a massive 355 billion total parameters, which sounds computationally expensive. But here's the trick. For any single task, it only activates a small portion of them, about 32 billion. You can think of it like having a giant team of specialists, instead of asking every single specialist for their opinion on every question. The model intelligently routes the problem to only the most relevant experts. This sparse activation approach gives it the power of a huge model without the massive cost for every single inference. But the architecture gets even more interesting. Z.ai engineered it as a hybrid thinking system with 2 distinct operational modes. First, there's the deep thinking mode. This is for the really tough problems that require multi-step reasoning, planning, or using external tools. It's when the model needs to slow down and really think. Then, there's the fast response mode, which does the opposite. It trades that deep complexity for speed, designed to give you a quick answer when that's all you need. This dual-mode capability is built directly into its foundation, making it incredibly flexible. Okay, a flexible architecture is great, but the real question is, can it deliver? The answer is a sounding yes. When put to the test, GLM 4.5 performance is nothing short of jaw-dropping. On paper, it shows incredibly strong performance across 12 major benchmarks covering reasoning, math, and coding. It ranks 3rd globally, right behind OpenAI's O3 model and Grok 4, and consistently outperforms major competitors like Claude 4 Opus, Gemini 2.5 Pro, and DeepSeek R1. For example, on a benchmark testing web research agent capabilities, GLM 4.5 scored significantly higher than Claude 4 Opus, showcasing its superior agentic skills. But benchmarks are one thing. What Z.ai showed in their live demos is what really sells it. They had the model build a complete Flappy Bird game from scratch. We're talking all the logic and animation just from a simple prompt. Even more impressively, they demonstrated it building an entire full-stack web application. Through a multi-turn conversation, it created the front end, the back end, the database, and even handled deployment. The final result was a fully functional site with clean code. This isn't just about answering questions. It's about building complex, working software on command. But all that power and performance is only half the story. Here's the real game changer, and what makes GLM 4.5 so strategically important. It's open source and incredibly cheap. The model is released under the MIT license, which means it's not just free to download and inspect. It is fully commercially usable. You can grab the weights from platforms like Hugging Face and build it directly into your products without paying licensing fees. Then there's the price. The API costs are stunningly low, at around 39 US cents per million tokens. That's a fraction of what you'd pay for competing models from companies like Anthropic, Google, and even the already cheap DeepSeek models. This isn't just about being affordable. It's a direct challenge to the expensive, closed-source ecosystem. By combining top-tier performance with radical accessibility, Z.ai is positioning GLM 4.5 to become a new standard for developers and businesses everywhere. So, what's the big takeaway? GLM 4.5 is a powerhouse. It's a highly capable, efficient, and versatile open-source AI that truly excels at reasoning, coding, and agent tasks. When you combine that top-tier performance with its fully commercial open-source license and disruptively low cost, you get more than just a new model. You get a genuine game-changer that makes elite AI capabilities accessible to everyone. And that's why it's such a big deal. Now, let's explore another new released open-source model. This one is a non-thinking model, nevertheless. It achieves state-of-the-art performance in frontier knowledge, math, and coding. It's called Kimi K2, and it's already challenging industry giants like GPT-4 and Claude. So, what exactly is Kimi K2? It's a groundbreaking and completely open-source AI. And when I say it's big, I mean it's a massive 1 trillion parameter model. But what truly sets it apart is its core design. Kimi K2 wasn't built to be just another chatbot. It was meticulously optimized for what's called agentic intelligence. This means it's designed to do things, to use tools, solve problems, and autonomously complete tasks. Kimi K2 is built on what's called a mixture of experts, or MOE, architecture. The easiest way to think about this is like having a massive team of specialists. While the entire team has a mind-boggling 1 trillion members, that's 1 trillion total parameters for any given task. The model intelligently calls on only the 32 billion most relevant experts. This makes it both incredibly powerful and surprisingly efficient. To build its knowledge, Kimi K2 was pre-trained on a staggering 15.5 trillion tokens of data. But here's the part that has developers really excited. The training process was incredibly stable. For a model of this scale, that's almost unheard of. Its training loss curve is remarkably smooth, with 0 training spikes. This isn't just a technical detail, it's a sign of a major breakthrough in how to successfully build and scale these giant AI models. But all that technical power we just talked about, what is it actually for? This is where Kimi K2 goes beyond just being a powerful language model and becomes something truly special. It has been meticulously optimized for agentic tasks. In simple terms, it's not just a talker, it's a doer. This model shows incredible proficiency in coding, using external tools and autonomous problem-solving. Instead of just answering a question, it can be given a goal and then take steps to achieve it. Think about asking it to analyze a complex dataset. It could write and execute the Python code, generate charts, and give you a summary, all in one go. What makes these complex multi-step tasks possible is its absolutely massive context window. Kimi K2 can support up to 2 million tokens. That's like giving it the ability to read and remember an entire book or a huge codebase all at once. This enormous memory allows it to keep track of complex instructions, maintain context throughout a long project, and reason through problems without losing the plot. It's this combination of action-oriented design and a colossal memory that makes it a true agent. Okay, so we know it's designed to be a powerful agent. But how does Kimi K2 actually perform when it's put to the test against the biggest names in AI? Well, the numbers are pretty stunning. This isn't just a case of being good for an open-source model. Kimi K2 is a frontier-level competitor, period. In the world of coding, it's an absolute beast, even surpassing the mighty Claude for Opus on the live Codebench benchmark. But it's not just about code. When it comes to complex math and frontier knowledge, it's a chart topper. On benchmarks like a MEET 2025 for math and GPQA Diamond for expert-level questions, it ranks number 1, outperforming both Claude for Opus and Gemini 2.5 Flash. And here's the kicker. It's achieving these incredible results without a dedicated reasoning version, which is still on the way. It's not just competing, it's winning. But here's the part that truly changes the game. All that power, all those benchmark-topping scores. Kimi K2 is completely open source. This is a massive deal. We're talking about a frontier-level agentic model whose weights, technical blog, and even its training process are publicly available. It's not locked away in a corporate vault. This democratizes advanced AI, putting incredible power into the hands of developers, researchers, and creators everywhere. It means the entire community can build on it, experiment, and accelerate innovation. And you can access it right now. The model's weights are on GitHub. You can try it directly at Kimi.ai, or use it through various providers like OpenRouter. The revolution isn't just coming, it's here, and it's open to everyone. So, let's boil it all down. Kimi K2 is a massive 1 trillion parameter model that's not just powerful, but also incredibly stable. It's designed from the ground up for agentic tasks to act, not just talk. It's setting new performance standards, beating giants like Claude and Gemini in key areas. And the most crucial part, it's completely open source. Now that we reviewed 2 models from China, let's dive into the open-weight models released from the biggest AI US company, the GPT-OSS models. What exactly are these GPT-OSS models? Well, they're OpenAI's most anticipated open-weight reasoning models, named GPT-OSS 120B and GPT-OSS 20B. Both of these are mixture of experts models, and they're released under a very developer-friendly Apache 2.0 license. What's their main purpose? They're built for powerful reasoning and tackling complex agentic tasks, making them incredibly versatile for developers. So, what makes these GPT-OSS models tick? Both the GPT-OSS 120B and GPT-OSS 20B models are built on mixture of experts architecture. This sophisticated design helps them balance performance with efficiency. The larger GPT-OSS 120B, with its 117 billion parameters, can actually run on a single 80 GB GPU, like an NVIDIA A100, activating about 5.1 billion parameters per token during inference. That's pretty efficient for its size. Then there's the GPT-OSS 20B, a smaller but still powerful model with 21 billion parameters. What's really cool about this one is you can run it on a laptop with just 16 gigabytes of memory. It's making it perfect for private or offline solutions. It activates around 3.6 billion parameters per token. Both models boast an impressive context length of up to 128,000 tokens, meaning they can process a huge amount of information at once. They were primarily trained on English text with a strong emphasis on science, technology, engineering, mathematics, coding, and general knowledge. Plus, OpenAI even open-sourced the tokenizer used for GPT-4 Mini and GPT-4, called O200K Harmony, alongside these models. Beyond just their impressive specs, a significant innovation with GPT-OSS models lies in their advanced reasoning and agentic capabilities. These aren't just models that spit out answers. They're designed to think through problems. A core feature is their ability to apply chain-of-thought reasoning. This means they can break down complex problems into smaller, more manageable steps, which really enhances their problem-solving skills and helps them generate more coherent, well-supported responses. What's even more powerful is their direct integration of tool use. Imagine a model that can decide to use a web search to gather real-time information, or execute Python code to perform calculations, all within its own thinking process before it even gives you an answer. This isn't about you setting up complex agent architectures. The models can invoke these tool calls themselves. This seamless blend of reasoning and tool utilization makes GPT-OSS models exceptionally well-suited for building sophisticated agentic applications to solve problems in a structured, dynamic way. So, how do these GPT-OSS models actually perform in the real world? Well, when you look at the benchmarks, it's clear they're punching way above their weight. Despite being considerably smaller than many leading models out there, GPT-OSS models show seriously impressive performance. They generally outperform OpenAI O3 Mini across the board, even without using external tools. And when stacked against the full O3 model, they're incredibly competitive with some of the latest frontier models. For instance, on the challenging GPQA Diamond benchmark, The GPT-OSS 120B achieved an impressive 80.1%, with the 20 billion model hitting 71.5%. On the MMLU benchmark, the 120 billion scored a fantastic 90%, and the 20B wasn't far behind at 85.3%. These are really strong scores for open-weight models, putting them very close to, and often outperforming models like OpenAI's O3 and even O4 Mini in areas like competition math. So, we've seen how powerful these GPT-OSS models are in terms of performance. But what makes them truly game-changing is their accessibility and cost-effectiveness, largely thanks to their open-source nature. Developers and researchers now have multiple ways to get their hands on these models. You can find them readily available on platforms like Hugging Face for direct download. If you prefer running things locally, Llama is a fantastic option. You can simply install it and download the 20B model or pull down the 120B if you have the hardware. OpenAI utilizes quantization to reduce the memory footprint of the GPT-OSS models. The models are post-trained with quantization of the mixture of experts weights to MXFP for format, where the weights are quantized to 4.25 bits per parameter. The MO weights are responsible for 90% of the total parameter count, and quantizing these to MXFP enables the smaller model to run on systems with as little as 16 gigabytes memory, and the larger model to fit on a single 80 gigabytes GPU. This open-source release has also sparked fierce competition among cloud providers. Platforms like OpenRouter are already offering GPT-OSS models at incredibly competitive prices. We're talking about the GPT-OSS 120B model being as low as 10 cents per million input tokens, and the smaller GPT-OSS 20B for just 5 cents per million input tokens, or even for free. This intense competition ensures fast, low-latency inference at a fraction of the cost you might expect for such capable models. Beyond the immediate benefits of accessibility and competitive pricing, OpenAI's decision to release GPT-OSS marks a truly significant moment. It's their first open-weight model release since GPT-2, signaling a philosophical recalibration and a return to the collaborative spirit that once defined the AI community. So, in a nutshell, OpenAI's GPT-OSS models mark a significant return to open-weight AI. They offer powerful reasoning and agentic capabilities, are highly accessible on various platforms, and their open-source nature drives competitive low-cost inference. This truly democratizes advanced AI for developers. So, my thoughts about the last developments in open-source models are: this move acknowledges that real progress thrives on transparency, accessibility, and the collective ingenuity of diverse minds. For developers, it's a game-changer. They can now break free from vendor lock-in, customize these powerful models, and run them locally or on cost-effective cloud solutions. This fosters a vibrant ecosystem of innovation, encouraging widespread experimentation and customization that simply wasn't possible with purely proprietary models. It injects a new dynamism into the AI landscape, sparking more competition, more collaboration, and ultimately democratizing access to cutting-edge AI for everyone. If you found this helpful, please like and subscribe. What are your thoughts about those new open-source models? Let us know in the comments. And thanks for watching.